So now that you know all the basics of a tsunami, let's look at some historical tsunamis just for context, right? We said underwater volcanic eruptions can cause tsunamis. An explosion of a island can also cause this. So Krakatau, an Indonesian island in 1883, exploded, so much so that the entire world heard the sound. It's supposedly the loudest sound ever made by a non-human activity on Earth. Okay, Scotch Cap, Alaska Hilo, Hawaii, 1946, caused by a magnitude 7.3 earthquake in the Aleutian Trench. Aleutian Islands are these islands that run from Alaska towards Asia in the North Pacific. Papua New Guinea in 1998, very recent, part of the Pacific Ring of Fire earthquake, a magnitude 7.1. We haven't talked about magnitude of earthquakes, but basically it's a Richter scale, the log scale. So difference between 7.1 and 7.3 is not very small. A log of a number that gives you 7.1 and 7.3 is a massive difference. So each decimal point change in the Richter scale, earthquake magnitude is a massive change in magnitude. So here is our ring of fire. You have the various trenches. Aleutian Trench is this one. The island chain goes from Alaska, Gulf of Alaska towards Asia, towards Russia. You have the Cascadia Subduction Trench, the Middle American Trench, the Peru-Chile Trench, and so on and so forth. So this entire region is plate tectonically very active, which means plates are crushing each other, subducting, and they can always create tsunamis. So these are the various tsunamis, and then there is a Sunda arc here. That is where the Australian plate is subducting under the Indian Asian plate. So here is a table of many significant tsunamis since 1990. I think throughout the 20th century there have been about just about 500 tsunamis, which means you get about 5 tsunamis per year on average. Obviously that's not a constant number. You can see here. So you have 1992, 2, 93, 1, 94, 95, and so on. Between 98 and 2004, so the New Guinea and the big Sumatra tsunami, there wasn't much activity. Geologists can tell you how the stress builds up and then how big the earthquake gets and so on. We won't get into that, but essentially it tells you that just since 1990 there have been lots of tsunamis with tsunami heights ranging from just 10 meters or 3 meters up to 26, 30 meters. This one is 40 meters, or the Tohoku, Japan tsunami. Why is it famous? It not only killed a lot of people, second to this December 2004 tsunami after Christmas Day. Remember, this is local time, so it was still Christmas Day in the Western Hemisphere. So 3,000, more than 300,000 people there, and almost 20,000, but this number is still probably not very accurate. Nonetheless, this is famous because it created a huge tsunami that actually went inland. There were all kinds of problems in the warning system. Japanese have been getting these tsunami warnings like the tornado warnings in the southeastern US, in Oklahoma, Texas, and so on. Everybody is used to listening to the warning and taking action. But obviously, if there are many false alarms, then people don't act rapidly. Apparently there were some miscommunications as well as some wrong forecasts made. People didn't take action, and the tsunami turned out to be much bigger than forecasted, and many people got caught by surprise. But the biggest disaster that came out of that was that the tsunami that generated went onto land and damaged a nuclear plant, the Fukushima Daiichi nuclear plant. which released a lot of radiation, had a lot of damage, put Japan out of power for I think several weeks in some places. And the radiation and the debris that was released by this tsunami floated around for a long time, and the radiation was distributed all the way across to the west coast and so on by the ocean currents, and going to the depth by the water circulation and so on and so forth. So, and it changed the Japanese psyche about relying on nuclear power a lot. They have a very small land space. They don't have coal and so on, so they rely a lot on nuclear power. So obviously this changed their calculation. It had consequences for climate change, because if Japan decided to abandon nuclear power and go back to coal, that's going to increase greenhouse gases and so on. So there are all kinds of issues. But you can imagine that the Japanese are used to tsunamis. That's how they invented this name, tsunami, the harbor wave. The Indian Ocean tsunami, the other big one, massive earthquake from 7.3 to 9.2 is a huge change. It happened 1,200 kilometers it happened away from the coast, as we said, deep in the ocean. 1,200 kilometers of the sea floor was displaced between two tectonic plates, and there was a vertical movement of probably 30 meters, if I'm not mistaken. And the Tohoku tsunami actually moved the island of Japan by 4 meters, I think. So the earthquake was so powerful that it moved an entire island. So that's geology for you. That's not a joke, right? So you can see here the start of a tsunami, and then it radiates out step by step. It moves very fast, as we said. It just happened that there was a JSON satellite altimeter. Remember, altimeter measures the sea surface height by shooting a laser and measuring the time of return. It was flying overhead, and it produced some beautiful data a few hours after. So the satellite overpass started to happen here. It passed over certain several crests and troughs of the tsunami. You can see the tsunami crests and troughs radiating out from this epicenter of the earthquake, and you can see the satellite data clearly recording the sea level height. Remember, the open ocean sea level change is very small, as we said. It's when these very fast moving waves begin to hit the coast and begin to pile up the water that you get these massive wall of tsunami coming in and destroying everything in its way. Okay, so the Tohoku earthquake, there we go, a 9.0 earthquake in the Japan Trench. It was felt throughout the Pacific, the most expensive tsunami in history. The initial surge was 15 meters, not forecasted very well. It topped the harbor protecting tsunami wall. So people thought, based on the forecast, that there is a tsunami wall that'll protect us, but actually it ran over it and got amplified by the local topography, like water running between the streets, between buildings, and then getting amplified and so on. So almost 20,000 people died. The number is supposed to be much higher, but this is the official number. And as I mentioned, this disrupted the power at Fukushima Daiichi nuclear power plant, and the reactors exploded. Radioactivity was released into the ocean, into the air, caused national trauma that still goes on in many ways in Japan. So tsunami is a rare event, but when it happens, it can create massive damage. Okay, so we'll look at tsunami forecasting. I mentioned it already that Japan didn't forecast the Tohoku tsunami very well. So we'll see exactly how it is done in the next podcast.